Welcome back. Let's talk about the normality equation. According to the law of chemical equivalence, in any reaction, say A plus B gives AB, then the equivalences of all the reactants and that of the products are equal. That is, the equivalence of reactant A will be equal to the equivalence of reactant B, and that will be equal to the equivalences of the product AB. This is known as the law of chemical equivalence. Now, as we know from the definition of normality, normality is equal to equivalence by volume in liters. This implies equivalence will be equal to normality into volume. So, while putting this equivalence into the above equation, we can get this kind of expression. That is, NAVA will be equal to NBVB. A stands for reactant A, while B stands for the reactant B. This expression is known as the normality equation. This equation carries huge significance in chemistry as it solves all the problems of stoichiometry, including the dilutions, and it does not require chemical equation to be balanced. Moreover, as we know, normality has got a relation with molarity by way of n factor. So n factor is equal to n by m, from which normality will be equal to n into m, where n is actually n factor. Using this relation in the normality equation, we can get Na MAVA, that will be equal to NB MBVB, where Na and Nb are not the moles, but they are the n factor values for the corresponding reactants A and B respectively. This expression is known as the molarity equation. Thus, while using molarity equation, we need to find out the n factor values of corresponding reactants, but in the case of normality equation, no need to find the n factor values or make the equation balanced. This implies normality equation is much easier to use as compared to the molarity equation. Now let's illustrate these equations with certain examples. So we have the first illustration that tells us find the normality of sodium hydroxide if its 10 ml are used to completely neutralize 5 ml of 2 normal HCl solution. Clearly, the reaction between sodium hydroxide and hydrochloric acid is actually an acid-base neutralization reaction. So the equivalences of sodium hydroxide will be equal to the equivalences of hydrochloric acid. So in order to find out the normality of sodium hydroxide, we can use the normality equation. That is, N into V of sodium hydroxide will be equal to N into V of HCl. Now, normality of sodium hydroxide we need to find out. Volume of sodium hydroxide is given as 10 ml, so that will be equal to 10 divided by 1000 in liters. Similarly, in case of HCl, normality is given as 2. Volume is equal to 5 per 1000 in liters. While putting the values in the expression, we can get N into 10 by 1000. That equals to 2 into 5 by 1000. Upon solving this equation, the normality of sodium hydroxide comes out to be 1. In the same way, we have the next illustration that tells us if 100 ml of 2 normal hydrochloric acid solution is diluted to 200 ml, then the normality of final solution is. So in this case, we are basically diluting 2 normal hydrochloric acid solution whose volume is given as 100 ml, and we dilute it to 200 ml. So we know now the volume of final solution, that's 200 ml. The volume of initial solution is 100 ml, and the initial normality is 2 normal. So we can easily use the normality equation, that is N into V of initial, that will be equal to N into V of final. Initial normality is given as 2. Initial volume is given as 100 ml, so that's equal to 100 by 1000 in liters. Final normality we need to find out, and final volume is equal to 200 by 1000 in liters. While putting the values in the expression, we get 2 multiplied by 100 by 1000, that equals to normality into 200 by 1000. Upon solving this expression, the normality of final solution is equal to 1. I hope you understand this. Now I'm asking you to find out the molarity of sodium hydroxide if its 10 ml are used to completely neutralize 10 ml of 2 molar sulfuric acid. Once you finish up, please write the answers in the comments. Till then, take good care of yourselves. Thank you.